Aloha and welcome to the Digits PostgreSQL WAD. This is a pretty good one. We're finally going to hook up our Digits application to a backend database. And you're going to find, I think, in this WAD that given all of the preparation that we've made, this is not going to be that difficult a process. At least that's what I'm hoping. Of course, you should have completed the Digits normalization WAD before that. Before this one, because we're going to rely heavily on that code. So the first thing we have to do is start the timer, and then we want to create a branch off of master, which you should have merged in from normalization, of course, called what? PostgreSQL1. So here we are, PostgreSQL1 branch. And we want to make sure the check style passes, so we'll do a propeller option shift I, run check style, custom scope default, no suspicious code found. He looked at the bottom of the window. And then we could do an activator test to see that the test cases pass. And after too much time has passed, we find that they have passed. Okay, so we're all ready to go. So the first thing we want to do is use the PSQL command line tool to create a new database in our local Postgres server called Digits. If you're starting over, you may want to drop the database and create a new one from scratch. So we'll run PSQL down here. We'll create database Digits, semicolon. And as I suspected, it's going to say it already exists because I've, worked on this before as I was generating materials. So just in case, you need to see this, we can drop the database here, and then we can create database Digits again. And now we've got our digit, and we can do a \L to list the databases and see that it's there. So looks like we're all good. And now we want to update the build.sbt and application.conf files according to the Postgres, the play example Postgres system, which I happen to have right here. A lot easier to use it in IntelliJ than go to GitHub and be copying and pasting. So here's the application conf down here well, we'll start with build.sbt, I guess. So here's build.sbt for digits, and here's build.sbt for play example Postgres, and what you'll see is really the only thing, well, you want to make sure JDBC and Java EBean are in there, and they usually are. In the case of this, because I built off of some other play template, I've got these other libraries that are in there, and that's fine. So you add a comma, and then you paste in this. And as long as we have JDBC, Java EBean, and this Postgres thing, we're all good. So I'll do refresh, so it's going to make the system again. Make sure that they can find that library. And while it's doing that, we'll go on to look at application.conf, which is the other file we have to fiddle around with. And so if we go to the top, you can see that there's this other line for application secret. This is basically not that relevant to this WAD, but I'm going to add it in anyway, just for future, because it turns out that when you deploy to Heroku, you should not be using the application secret that's embedded in the source code. And so this enables you to define an environment variable at Heroku with a hidden application secret value, which will be used instead of this local one for development purposes only. Application langs.english, we've got that one already. And then we get down here to this database configuration. And so we want to take this and paste it. And the big bugaboo here is to make sure that you actually update that part of the string with the database name. Make sure that you've got this, that you're still ending with a quotation mark, otherwise you have problems. If you don't update this, everything will appear to work fine for a while because you'll be adding tables to that other database if you happen to have it. and but then things will go awry eventually. So make sure that that's the correct database. And then the next thing is that we want to, for development purposes in particular, we want to have this evolutions enabled. That's going to mean that Play will actually look, well, the Object Relational Manager, in this case eBean, is going to look at our model definitions. That means contact, telephone type, and die type. And it will actually generate the SQL statements necessary to build the corresponding tables in the database. And also even execute those SQL commands if it finds that those tables aren't there. So that's going to really simplify your life, because you basically end up having to know no SQL at all to build the applications. Once you go into production, then life gets more complicated, because the issue with evolutions, they work great until you actually want to evolve, at which point you change your domain model, and then it regenerates or it generates updates, and generally that means that it's going to drop all the data from your database in order to rebuild it with this new structure. That's really good during development, because during development you generally don't care about your data. During production, of course, you don't want to have this happen. At that point, what you end up doing is needing to kind of manually update the database and fix any things that have changed due to your changes in the domain model. But for right now, we can really simplify our lives a lot by saying we don't care if the data goes away. What we care about is simplifying the maintenance of the relationship between our domain model in Java and the underlying relational database tables. Okay, and then there's this eBean default. We need to do that because eBean likes to know where it should look for the model classes. So that's all for application conf, and so yeah, we'll add that to Git. So we've updated build.sbt application conf, we've edited the database URL string, and now the next thing we want to do is deal with the entity annotations. And we're going to go to the model implementation guidelines, and what you'll see here actually is, here's a little guideline to what we just did. And then it's going to stress that we need to create private fields and public getters and setters for all entity classes, because otherwise eBean can do some very subtle but wrong things. And so I just emphasize this. And then I have this best practice checklist, which is essentially a way to not have to think too hard about making Java classes into entities using the eBean ORM. So we'll start with contact. And the first thing it says is we need this to extend model. And that's the correct one. So we'll do option return. And then the second step is to annotate with @entity. So we'll do @entity, and Java X Persistence is the right package, so we'll import that. And all fields must be private and have public getters and setters as noted above. So what I'm going to do is I'm going to just basically check to make sure that that's true. So I'll hit getter and setter, and it says no fields without getter and setter found. So that's guarantees that we've satisfied that. Then we're going to have a long ID field annotated with @ID. So I'm going to go @ID. And then it's going to want to import it from javax.persistence, which is the right spot. So that's done. And that's going to be the primary key. And then we have this static public find method returning a finder instance. So this is the way eBean, we're not going to use SQL statements to go look for things. We're going to use this specialized query language that eBean defines. And it's actually quite a sweet little query language, actually. And so you have to get used to it a little bit. It's yet another little library thing you have to learn, but there's only kind of, I don't know, a half dozen methods you have to know in this thing, and you can pretty much do what you want. Okay, so we got the eBean ORM, and then we have a field for all relationships this entity participates in, which means those are the two fields for the two relationships it participates in, and they're going to be bidirectional. We'll see that in a second. We're going to annotate each relationship with at one-to-one, at many-to-one, or many-to-many, and supply the map by parameter as needed. So for this, I'll kind of talk through as you do it, but you'll want to go through and read this stuff as you start thinking about this in order to understand what you want to do. So we need to, so this is a relationship, we need to annotate it with what kind of relationship it is. And what we can say in this case is that this is a case where many contacts map to just one of a telephone type. Okay. On the other hand, we can say here that many contacts map to many of the diet types. That's a many-to-many relationship. Okay, so in other words, many different contacts could all have the same telephone type, mobile. Okay. On the other hand, many of the contacts also can map to many different diet types, because we can have beef, chicken, fish, etc. All for an individual contact, and all the different contacts can have any combination of diet types. So it's a many-to-many relationship. Okay, so that's the way this one works. And what we're going to do is we're going to map we're going to use these two fields, telephone type and diet types, as the fields which are going to store these relationships. So we're going to do the mapped by in these other entities. So let's go on and go to diet type and start over from the top here and say extends model. And then, remember, I think it's like that. And then this is at entity. Okay. And then what's the next one? All fields must be private at public getters and setters. So we'll do propeller n, getter and setter. No fields without getter and setter. Okay, that's good. Have a long ID field. We have one of those. We gotta have this. Oops. ID, and then option return. Import that as the primary key, and then we've got to have one of these ebean finder methods. So we'll put that there, and then instead of foo, this one's going to be called diet type. Diet type and diet type. So there's our finder method, so that we can, you'll see how we use that in a minute, so we can go get diet types and do various things with them. A field for all relationships this entity participates in. So the relationship that a diet type participates in is with its contact. Okay, so in this case we say, again, like we were just talking about, it's many-to-many is the relationship that that contacts and diet types have. So if it's many-to-many on the contact side, obviously it's going to be many-to-many on the diet type side. And then we have this mapped by equals diet types, okay, that we're going to add. And what that's basically saying is if you go to the contact and you see this diet types field, that's where this relationship is actually going to be put. Okay? All right, so that's the diet type. We've got one more to do, which is telephone type. So we're going to extends model. This is the ebean model, which is going to give us methods like save, for example, so we can automatically persist this thing. And then at entity, okay, and that's a JPA annotation, which ebean implements most of. So if you're using Hibernate or some other object relational manager, you'll see a lot of these same annotations, and they're used in the same way. So it's as you get familiar with this, you'll be able to reuse this in other settings. So there's our primary key, and then we got to do our find method. So we'll add this finder, so that we can retrieve telephone types whenever we want from the underlying database. Okay, and then there's that, and then we have a field for all relationships. So this participates in a relationship with contacts, so we have a field for it. And then in this case, we say that one telephone type participates in a relationship with many different contact types, right? And again, we're going to say the mapped by parameter equals telephone type. So we're having that go to this field. This is the field that's going to, implement that particular relationship. Okay, so we go back to telephone type. So we got that mapped by. And we got to make sure. Let's just make sure that we've got all our getters and setters. Okay, so we're still good with that. Okay, so we've annotated each relationship. So we've gone through our 3 entities, gone through this checklist. That all looks pretty good. Okay, so we've updated. So we're going to add the cascade equals cascade type dot persist to contact relationships. Now this, excuse me, I guess I'll just open this up in a new tab. We do talk about this later on in the this best practices document that we can use this so that when we save one instance, so for example, when we save the when we save an instance of a contact entity, what would be nice is if there are updated versions of telephone type or diet type entities, those got persisted as well. And it turns out there is a very convenient way to do that, which is we'll just take this kind of argument to the these annotations, and we add this. And I know this looks like black magic, but doggone it. But that's it's just part of the language of doing this kind of object relational management, and I'm hoping that as you kind of just go work through these things and add them, they'll start to make more sense. It'll all come together for you, I think, eventually. Even if it feels mechanical at first, that's okay. Just kind of keep watching this and keep going through it, and it'll sink in. Okay, so what this means now is when we save out a contact instance, because we've got this cascading persistence thing, the object relational manager is going to go through this field and say, hey, does that telephone type instance need to be persisted? If so, I'll automatically call save on that as well. Okay, that's super nice. Okay, so the next thing we have to do is modify ContactDB to use Postgres rather than using these in-memory database. So let's go here. And what you got to remember is that up till now we've had these in-memory data structures, these maps. Okay, and what we're going to do to kind of wean ourselves off those maps is just comment them out. I think that's the easiest way to do it. Okay, so which means that now this thing isn't going to compile anymore. You can see red, all the way through here. And what that red indicates, anytime you see red, you're seeing a situation in which instead of using these in-memory data structures, we now have to go out to Postgres and query Postgres for the data. So let's see how that that all works. We'll start down here with add a telephone type. Okay, so this is an operation where we basically want we've got this new telephone type entity instance, and we want to save it, right? And before, the way we saved it was by putting it into this in-memory data structure. But now life gets actually a lot simpler. We'll just call the save method. Let me delete this. Do command delete. Okay, and that's how we add a telephone type. Similarly, to add a diet type, instead of saying putting it into this in-memory data structure. Let's delete that line, and instead say diet type dot save. Okay, so that's what we're going to do with those. Okay, now here's a situation where we're given a string that's the name of a telephone type, like work, mobile, home. And what we want to do is, and what we're currently doing is getting that telephone type out of our in-memory data structure. So what we want to do instead is we want to say telephone type. Let me just, it's silly to do it that way. Let me just delete this because we know that that's wrong. So what we're going to say instead is we're going to say telephone type. Now we're going to use this query, this method we just defined called find, and we're going to say where. This is the language, so we're going to find where. We're going to use the eq method, and the eq method says take a field. Here's the field that we're interested in, and we want that field, we want to find an instance of a telephone type where the telephone type field is eq or equal to type string. Okay? And furthermore, we want to guarantee that there's only one instance in that table that has that value. And if that's so, it's going to return the actual Java class instance associated with that telephone type. Okay? And then if it can't find it, it's going to return null, it turns out. And that's a good thing, because if it returns null, we're going to throw a runtime exception. Okay? So very similarly, we will say diet type dot find, and whatever, and I'll say where eq, and this is diet type type string dot find unique. Let me just make sure. Is that what it's called again? Yeah, diet type. Okay. And again, if it can't find a unique one, it's going to return null if there's none in there like that, and then we'll throw a runtime exception. Okay, so down here we need to get a contact given its ID. All right. Well, that turns out to be quite simple. We'll call our find, and we'll say by ID. Bam. All right. No biggie. All right, and then this last one says we want to return a list of all the contacts. Well, how do we do that? So as you might be expecting by now, we're going to say contact dot find, and then we'll say all. And there we have our list of contacts. Okay, so that gets rid of a lot of things. We don't need this now. And so here's another situation where the intent of this, before was to save out this contact in our in-memory data structure. So what am I going to do instead? I'll give you a couple seconds. Think to yourself, this is going to be contact.save. Okay. All right. So let's see. Okay, so the next thing we'll do is we've still got this piece of red because we've commented out the current ID. And what this means, the reason why this is, I'm going to just delete this now, is because once we have an underlying Postgres database or any database, databases are going to manage the IDs. So we were doing that manually before because we weren't a database. And now what we're going to do is just say, there's no reason for us to be passing in IDs and assigning them. That's all going to be done by Postgres. So the best thing to do is to simply completely get rid of that reference to an ID, and that's the underlying objects are going to be constructed by Postgres with the ID that's required, and we don't ever have to worry about it. Okay, so there's that. And I think I don't see any red lines. So it looks like we got rid of all the compilation errors. But there's one important thing we need to do, which is to make the relationships bidirectional. Okay, and that was something that didn't exist before in our digits database, but one of my guidelines for using, relational databases is just to make the relationships bidirectional, because it just gives you so much more flexibility in how you manipulate your data later on. So we're going to say make relationships, and it's not a big deal to do. And here's how you do it. Okay, all you really need to do is say, okay, I've got myself a telephone type right here, okay, and I'm adding it to contact. So all I want to do right here is just say telephone type, telephone type dot add contact. Okay, and that's making, since contact was just create the relationship to telephone type, now we're having the back relationship from telephone type back to contact. And we'll do the same thing for diet types. Unfortunately, it's a tiny bit more complicated because we have to say for diet type in diet types. And really, with Java 8, we could do a nice little lambda, like a little mapping over this to do this really easily. But I'll just stick to Java 6 for the moment. Anyway, diet type dot add contact. Okay, so we've made our relationships bidirectional, and now we're going to call contact save. And the beauty of this is that when we call contact save, okay, because of this cascading persistence, what it means is that, let me just get that later. What it means is that saving out this contact is going to lead to saving out the telephone type instance and the diet type instances that we've just updated. Okay, so we don't have to kind of go through and save telephone type and save diet type. We'll get that done for us. All right, so that's the contact DB part of things. Now we have to update the global class to only create entities where none previously existed. So beforehand, when we were starting from scratch every time, we always had to initialize the system, but now we've got a backend database. So once we've initialized it once, we don't want to initialize it anymore, otherwise we'll have duplicate things in there. So, a few different ways we could do this. I'll just do it in one way. It's a little more redundant, but it gives you more kind of experience looking at this. So we could say, if data, one way to do this is kind of it's not the most efficient way, but it's a really simple way, is we'll just get all of the telephone type instances, of which there is a maximum of 3, and if we don't find any, then we know we have to make them. Okay? And we can do the exact same thing for diet type. Dot all, get all of them, check to see if there is empty, and if it's empty, then let's create them. And then finally, we'll do the exact same thing for our contacts. If contact dot find dot all dot is empty, then we'll create some contacts. Okay. Ultimately, we probably won't even initialize. This last thing will get commented out. But just for now, you can do other things. You can check, how many rows there are. There's a few different ways you can do it. But this isn't that bad. You only do this once when the system's actually coming up. Okay, so there we've updated the global class. So actually now we should be ready to run the system. So I'm going to do an activator clean because I have been making changes to the application conf and various things, and started getting a little more nervous about Play's ability to um, clean up after itself, particularly when you're doing branching and moving back from master and so forth. So now we're going to run the system, and go here, and we'll say kabam. So now we're going to compile, and then we'll get, okay, so we got a problem. Tried to connect models.contact cannot be cast to models.contact. Well, that's pretty crazy. I'm not sure why that would be. Let's integrator run. Yeah, that's really strange. I'm sorry that I don't know why that happens, but then it doesn't happen anymore. It could be that when it's first setting up the evolutions that it's got that problem. But anyway, so here we are, and I'll make a new FOP John 808-999-1111. I'll take a look in Google on that message and see if I can find anything. So we've got basically our application just working fine, right? Even though we got that irritating error, but it looked a little fishy to me because it was saying it couldn't cast something to exactly itself. So in that case, it might be worth trying it one more time before you kind of give up, make sure it's repeatable. Okay, so one of the things I wanted to show you at this point was the ability to connect to the database within IntelliJ, which is kind of a cool thing to do. Oh, shoots, and I'll do it from scratch so that you can see what that looks like. So when I go to the View Tool Windows database, whoops, just got rid of it, you'll see this data source with propeller n. So we click propeller n, and then we go down that data source, and we want to connect to PostgreSQL, so we get this specific Postgres little dialog box. And all you really need to do is say digits as the name of the database and the user that you are. And we can try this test connection, and it says it was successful. So then we can do OK. And at that point, we've got this live connection to the database, so you can do things like double-click on a table and see the actual contents, which is really nice. And you can also see, for example, that we've got this junction table that connects this many-to-many relationship. And if you actually go look in our evolutions file, you can see the definitions, the SQL definitions that were generated by eBean by analyzing our model. And this is what they look like. And so all that stuff was kind of done for free for us without having to worry about it in a Postgres-specific manner. Okay, so the last thing that we're supposed to do here is to create a test class. Okay, so let me just. So to do that, I'm going to go to tests, and we're going to create a new kind of test class, which is going to be called model test. And probably the easiest way to do is go down here and look at the model test class. And we want to make a copy of it for starters. And I'll paste it right here so it stays in the test package, even though it's not in the test package in this one, but it should be in a normal system. Okay, and we're going to get rid of this stuff. So the idea here is that we're going to run a fake application with an in-memory database. So we're not actually going to connect to PostgreSQL. We're going to use this H2 database, which I say in our the readings that we don't want to use that in general, but except in the case of testing, it's okay. And the other thing to note is that I've just found that with 14.1, you can't run these kinds of model tests within IntelliJ. It's very irritating. They run just fine in the command shell, but not in IntelliJ. So just to get our feet wet, okay, let's just write a real simple assertion to make sure that things are kind of initialized correctly. And to do that, we could say that we want to find all of the telephone types, and we want to say the size of that resulting. Let's import that so it knows what we're doing here. Okay, so we want to assert that the size of this, all the telephone type instances, is equal to, whoops, I've done it, is equal to, and how many other? There's 3 of those things. Okay, so there's a real simple model-based assertion where we're going to our in-memory database after it's been set up, and we're checking to make sure that exactly 3 telephone types have been created. So just let's run this to see that we know what we're doing with tests. Okay, so we have 3 tests now. We passed 3. We can see there were 2 tests. Yes, there were 2 tests in the integration test, and then a model test had 1. So all is good. So what I wanted you to do is to check to see that the bidirectional relationships are preserved. Okay, so how do we do that? Well, I'm going to kind of show you how that works, and then you can do it from then on. Well, what we're going to do is we're going to get a telephone type instance out of our database, and we can do this as follows. And I'll say by ID, let's just get the first telephone type that exists. We don't really care which one it is, but we'll just get one. And then we want to get a diet type. Let's get one of those too. Equals diet type dot find dot by ID 1. Okay. And then we need to put that into a list. So we'll say list of diet type. Diet types equals new array list. Woo. Import that, and then we'll say diet types dot add diet type. Okay. Now what we can do, having done that, is we can say contact, and we'll import that, equals new contact, and a contact takes a first name, John, and a last name, Paul, and a telephone number, 808-808-8080, and a telephone type, which is an instance, which we've got one of now, as well as a list of diet types, which we have as well. So we got our contact. Okay, so we've created this contact. Now we want to save it into the database. Okay, so that's good. And having saved it into the database, the next thing we want to do is to make sure that that the bidirectional links are working. So in the case of diet type, I know because we've looked at our global, okay, there were no diet types. No diet types have any instances associated with them as a result of the initialization. So what we can say is we can say assert that diet type dot find dot by ID 1, and then we've got that gives us our diet type object. We'll get the contacts, and then we'll say how many of those are, and there should only be one of them. Okay, does that make sense? Okay, so let's save this out. Let's actually run this test right now to see if our assumptions are correct. Goodness. Oh, these should be longs. Doggone it. Right. 1L. I saw those red squiggles and I was ignoring them for some reason. But you can't ignore compilation errors. It turns out that's a very frustrating thing about computer programming. When things don't compile, you can't just run it. Okay, so that passes. So we've got the bidirectional relationship for diet types. Now the last thing is to see what about the telephone type. Okay, and in this case, we'll say assert that telephone type. It's kind of irritating to have that thing right there. Dot find dot by ID 1L dot get contacts dot size. And now the question is, what is it going to be equal to? Is it going to be equal to 1? Well, we got the very first one. And if we go back to global, that was mobile. And you can see we used mobile 3 times, okay, when we created these things. So this will, when we made our new one, that's actually going to be the 4th one that will exist there. So we'll put that like that. And we'll save it out. Let's try running activator test again. Okay, so there we've got an example of a test which actually assesses that we've saved an entity out, which updated the set of diet types and telephone types, and we've asserted that those happened. So the only other thing we have to do now is run checkstyle and see what we get. And of course we get a few things. So in contact.db, we've got 2 unused imports, so we'll delete those. Delete that. And in telephone type, oh, this was not preceded with white space. So we'll save that. And we'll do propeller shift checkstyle again. And no suspicious code found. We just ran we just ran this a second ago, so we know that that's our tests are passing. But I'll just do it again because it's always good to do it. So we're at 4404. Go to here. digits. Okay, and you see what we've updated quite a few things here. Our tests have passed. So I'm going to say finished WAD and commit and sync. And there you have, we'll call it 45 minutes for this kind of a long one. But we have accomplished a lot, and we wrote a test case for it. And we've got PostgreSQL working with digits, so that's a good thing.